Generation Robotics is a spin-off company of the Scuola Superiore Sant'Anna in Pisa. We stemmed out from the research activities of the university, and we worked in the sector of the human-robot interaction. We come from Pisa in Italy, where the Leaning Tower is basically. And our research background is in the field of the wearable robotics, teleoperation and collaborative robotics, mobile and inspection robotics. And from this last field, we started this technology transfer project, which is called Next Generation Robotics, our company, to bring our knowledge in the field of the Industry 4.0. This, as you can see from this scheme, the Industry 4.0 is based on the technologies 3.0, and together with enabling technologies like industrial IoT, big data analytics, and cybersecurity, together also with integrative technologies like artificial intelligence, simulation, digital twins, advanced manufacturing system technologies, additive manufacturing, in order to reach Industry 4.0. And predictive maintenance activities are in this field. Predictive maintenance is a last step for increase the system reliability. And in order to reach 4.0 predictive maintenance logics, data analytics, advanced sensor systems, and IoT are needed. Predictive maintenance is composed by a physical layer and a digital layer. In the physical layer, we have data collected by sensors that will be transferred to a cloud, where in the digital layer, digital twin and AI and machine learning perform data analytics in order to give results that, together with maintenance procedures and decisions upper systems, will give the response and the visualization of the data that can be used to optimize the intervention in the physical layer. What we do is try to transform inspection procedures, visual inspection procedures, in a 4.0 inspection procedure. The level of the inspection that we are working on is the first level inspection that conventionally is performed by people going under the trains and manually perform the visual inspection of components in order to identify wear or defects that can be solved by substituting the components or by intervening on the machines. And this is very expensive for the company also from the logistic point of view, because it is necessary to bring the trains in the depot. What we do is to create a robot that can be reliable and repeatable for automatic data acquisition, that can organize the data in a well-designed database, that can perform data analysis on AI-based algorithms, and finally, the optimization of the maintenance based on the data can be performed. The robot that we have developed is called Argo. This is the second version, Argo 2, and is a robot realized for autonomous inspection of rolling stocks. Here in this video, you can see basically how it works. The robot can go on the track. It's a very thin robot that can go under the train and perform the inspection. It has provided with 2 horizontal perspective cameras. Can perform fast camera scanning of the undercarriage of the train. Can also perform accurate scanning procedures, can recognize the interesting spots for the scanning and acquire images. It is provided with safety sensors, so it can stop. It has a layer for layer for safety. It is provided with an automatic rail installation system that can centering the robot in the rails while installed. And the most important thing is that it can work on every track. And so it doesn't need elevated pits or maintenance pits. It can work on standard railways or on sleepers. It is provided with an AI layer that can recognize the interesting mechanical components like screws or brake pads. It is fully controlled by an operator remotely via web app, so it can be controlled with a tablet or with a PC. And then the data can be sent directly to the company database. We have developed a free version of these robots. The first one and the second one has been developed together with Trenitalia, the main Italian train company. And the third version is born from a collaboration together with Deutsche Bahn in Germany. The main features of these robots are a robotic arm that can bring a pan and tilt camera close to the mechanical components in order to perform an accurate image acquisition of those components. Traction wheel, which is a patented system that take advantage of the rail web and the rail foot in order to perform the traction of the robot on the track. And of course, a thin profile in order to use the robot on every track. The system is intrinsically safe because it is very thin, and for this reason, trains can pass over the robot that can be installed permanently installed on the track, and it can perform also automatic scanning. It is provided with lights that can illuminate the undercarriage of the train, also in order to create a standard illumination for the acquisition of the pictures. And also it can perform measurements by using the two cameras with horizontal perspective. The robot can be remotely controlled from a position close to the robot or far to the robot. That is not a problem, and can be teleoperated manually. The web app provides the user with the streaming video, both of the navigation cameras in front and on the back of the robot, and the streaming of the inspection cameras, of course. And the robot can also perform automatic scanning of the train and then send all the data to the company database for the post-processing and the analysis. The third version that we have developed, the one developed together with Deutsche Bahn, has retractable wheels, also for overcoming the obstacles in the rail, like railway junction. Has an arm, a robotic arm with the pan and tilt camera, the two high-quality inspection cameras with horizontal perspective, and a safety layer in front and in the back with an emergency push button, and front, rear, and navigation cameras, and the laser collision avoidance system. This robot has been developed with a modular design. The modular design allows to have the very lightweight modules that can be managed by only two people, and that's very important also for moving the robot from one track to another one. And also, in this way, we can have one platform that can integrate many inspection functionalities. One module is designed for visual inspection. Then we have a central module with the traction and the main controller. And then we have a third module that can be customized with thermal inspection sensors or laser measurement sensors. Here in this video, you can see how the safety system works. And the robot, when detects an object in front of him, will slow down and then stop before the collision.
Can you move one step back?
When the obstacle is removed, the robot detects that can safely move, and it goes forward. Here you can see the pan and tilt camera and the robotic arm. The camera can perform 360 degrees rotation and 0.90 degrees rotation in the tilt direction. And then the robotic arm allows the motion in the vertical direction of the entire camera. Of course, the entire system is mounted on a linear guide that allows the camera to move and translate in the perpendicular direction. The AI layer that we have installed on the robot allows the recognition of the components, of the mechanical components, brake discs, brake pads, split spin, bolts, connections, and detect the correct presence of the components or the missing components. In what we are going to develop now is the capability to recognize also the defects on the components, and in order to integrate the predictive maintenance system. The data will be organized in a historical database for the association of the collected data to the inspected rolling stock via metadata. This allows also to filter the data and get the data, research data, have an historical database that can be accessed in any time for collecting, for analyzing or viewing all the data of or reviewing all the data of a specific rolling stock. Here you can appreciate the quality of the images acquired by the system on the left, and here on the right we have a demonstrative video on how to it's possible to view the map of the undercarriage of the train that has been reconstructed and can be interactively navigated by the operator in order to check the more interesting parts, components from the maintenance perspective. Unfortunately, in this case, the light was not the best possible, but it gives the idea of the possibility to navigate the undercarriage of the rolling stock. So thank you very much for your attention and for the